Good afternoon, my YouTube viewers. It is Crystal here. I just wanted to do another code review, and this code review is going to be about eigenvalues and eigenvectors. And what we're going to do is we've got the code in R, and we're going to translate it over to Python. But before I do that, what I wanted to do is I wanted to just give a little bit of introduction into what an actual eigenvalue and eigenvector is. So you've got the question, what is meant by eigenvalues and eigenvectors? Eigenvalues are the special set of scalar values that is associated with the set of linear equations, most probably in the matrix equations. The eigenvectors are also termed as characteristic roots. It is a non-zero vector that can be changed at most by its scalar factor after the application of linear transformations. So I think eigenvalues and eigenvectors are quite complex, but it is to do with linear algebra. And in my most recent blog post, I went into a little bit of detail about eigenvalues and eigenvectors, and I gave some code in Python to discuss that. And so I decided that what would be a really good idea would be able to give the code in R and Python. So this code review is a little bit different from what the previous blog post was. So we're going to look at R. So we're going to have it, because R is a different programming language than Python. R is a statistical programming language. So with R, we're going to create a matrix from a scale of 1 to 9, and we're going to make it a 3 by 3 matrix, which you can see it's been done over here. And then we're going to print, and it says cat the 3 by 3 matrix in. So we've got the 3 by 3 matrix. And then what we're going to do is we're going to print A. So this is your matrix here that's printed. And then we're going to print eigen A. So it's going to print your eigenvalues, which are right here. And it's going to print your eigenvectors, which are right here. And then in addition to a 3 by 3 matrix, what we're going to do is we're going to make a 2 by 2 matrix. And so that's going to be B. And then we're not going to do it as a 1 to 9. It's going to be B equals matrix brackets. C means that you put all the numbers together in an array. 2, 3, 5, 1. And then 2 means it's 2 columns by 2 rows, I believe. And then we're going to print B. So this is B after it's been printed. And then we're going to print the eigen of B. So you've got your eigenvalues here, and then we've got our vectors here. So those are your eigenvalues and your eigenvectors. But now what we want to do is we want to do it in Python. And in Python, they do things a little bit differently, because Python is a multi-purpose language. It wasn't made specifically with statistics in mind like R was. So what they have to do is they have to rely on libraries to help them do the things that they want to do. And in this case, we're going to be using Numpy, because Numpy enables you to do linear algebra, and the eigenvalues and the eigenvectors are related to linear algebra. So we're going to import Numpy as NP, and we're from Numpy lin alg, and we're going to import EIG. So the first thing we're going to do is we're going to create a Numpy array. M equals np dot arange 1 to 10, and we're going to increment it 1 times. m equals m dot reshape 3 by 3. So we're going to reshape it into a matrix of 3 by 3. But the way Python doesn't make its matrices the same way that R makes its matrices. Python does it by rows, like it'll be a row 0, and there'll be 1, 2, 3, and then row 1. Well, row 0, and then a 0, 1, 2, and then a row 1, 0, 1, 2, and then row 2, 0, 1, 2, because in Python the numbers start with 0. And since the arrays in Python are different from the arrays in R, what you have to do is you have to reshape the array, which we've already done, but then you have to transpose it. You have to transpose the array to get it to look like an R array. And then so we print mtrans.toList. So you've got your list of arrays, 147, 258, 369. And then now what we do is we do w, v equals mtrans, and we're going to print the eigenvector, print the eigenvalue, and then we're going to print the eigenvector. So you can see that we've got our eigenvalues printed and we got our eigenvectors printed. And you can see that the eigenvalues and the eigenvectors are the same. So the next thing we do, we just wanted to do another example. We create this 2 by 2 matrix. We're going to import Numpy as np from numpy.linalg import eig. B equals np.array2351. So we're going to take that list and we're going to convert it to a NumPy array. And the reason why we do that is because you cannot reshape a list. You can reshape an array, but you cannot reshape a list. And then b equals b.reshape 2, 2. And then again, the matrices in Python are different from the matrices in R. So what you need to do is you need to transpose it. So b trans equals b dot transpose. And then we say w, and we're going to print the transposed list so you can see, well, the transposed NumPy array or the transposed matrix, and you can see to 2531. So you come over here and you can see here 2531 as well. And then now what we're going to do, w, v equals eig, b trans. And so we're going to print the eigenvalue and the eigenvector. So we printed our eigenvalue and our eigenvector. And you can see over here, the eigenvalue and the eigenvector are the same. So you can see that we translated this from R to Python. So now you know how to do it in R and Python. So that concludes this code review, because that's what I wanted to do. I wanted to take code in R and translate it over to Python. And so you can see how it's done, and you can see how R and Python differ from each other and what you have to do to get a matrix in Python to look like an R matrix in R. So I'm going to go ahead and close this video. So I would like to thank all of my subscribers for supporting me. If you like my video, please like, subscribe, and share. And thank you very much for watching my code review. I look forward to making more code reviews for you in the future.